Hello friends, in this video we will see source degeneration current mirror and effect of source degeneration resistor, these resistors on mismatch. So let's simulate. We have actually already simulated in previous video while making previous video. Okay, so we have simulated this and okay. So let's plot current. So this is okay. One more thing. So we are taking same length for these devices, 4 micro, 4 micro, 4 micro, and we are comparing these three current mirrors. So in first one, this is simple current mirror with W by L 1 by 4 micro. Here we are adding 10k or 10k source degeneration resistor, and here we are adding 100k source degeneration resistance. Okay, so now let's see. We have plotted M9 and we are going to plot M11, M13. So from left to right, M9 to M11 to M13, we are adding source degeneration resistors. One is 10k, one is 100k. Now let's see. So for M9 we can observe that variation is more as compared to M11, and for M13 it is much more closer to input current, and variation also seems to be less and much closer to input current. So okay, let's see how much so both cursor if I put here, so say this is highest point and this seems to be lowest. So delta is coming minus 3.5 nano. So actually we are only varying threshold voltage. We are only varying threshold voltage. That's why this much less variation I think we are seeing. And if we see here, so let's see how much variation. This is minimum point, so 1.64 nanoampere. So as compared to 1 micro, this is not a huge variation actually, but in actual devices you will see more variation, and because you are not going to vary only threshold voltage, you are going to vary like width, length, or there will be a random variation in width, length, oxide thickness, then mobility. There can be many other parameters which vary. So this is just for example how you can do, and you can put your own variation in width and length using this command, using this command, this MC, this command you can put more variation by putting here this command. And other thing, like in mobility, you can put everywhere you can put this much, give this much of variation, and you will get more. Actually you will able to get more variation, and you can do more experiments. You can also model your all these variation difference in you can say VGS of these two devices by putting one voltage source and put say parameter TOL only. It will, you can consider it as a overall variation for device, and maybe you will get more varied results and more towards accuracy. So that is one way, by putting one voltage source here. Okay, so how we can put, okay, I will show you by example, and say I will take one voltage source and I will put source. So I will put this voltage source here and I will take this. So here say I am taking 5 milli star DOL. So even I am doing this putting this voltage source with the tolerance first time. Okay, it is not taking. No, it is not taking actually. Oh, it is taking. It is taking. So we will okay. So let's run once again and we will see whether variation or okay. So it is giving some error actually, unknown parameter TOL. Okay, so it is here, it is not taking tolerance like this. So, okay, so we need to put in different way. So let's see. So here I am taking, let's put in different way. Say 10 millivolt we want, and in that, so so maximum variation here will come like a 10 millivolt. So it will be like this. Now let's rerun once again. So we will do like this. Now let's plot current for all these three devices. M9, M11. Okay, so here M9 you can see variation is more, and as compared to M13 variation is less, because we are adding this source degeneration resistance. You can read theory for this, you can read out theory for this, or you can see previous video lectures actually. So but I am removing this because we are actually varying parameters. Thank you.